All right, this is lesson 7. We're going to be taking slices of right rectangular prisms with a plane. So before we begin, let's talk about what is a plane. A plane is a flat, two-dimensional shape, kind of like a piece of paper. It is a flat shape. What happens if we take a slice of a loaf of bread? So think about this. We have a loaf of bread, and when you take all the slices, do you notice that the slices are pretty similar? And that they actually take the shape of whatever the ends are. So when you take a slice of bread, it takes the shape of its ends. All right, so let's talk about what happens when we slice three-dimensional figures. So consider this ball B. This is figure 3. And we have a slice, a piece of paper that kind of goes right through it. It says, what figure does the slicing plane form? So this right here is where it slices that sphere. Notice that it takes the shape of a circle. Now, will all slices that pass through B be the same size? So if I slice it here in the middle, will that be the same size as I sliced it up here? And the answer obviously is no. Okay, because they will be all different sizes depending on where you slice it. Part C, how will the plane have to meet the ball so that the plane section consists of just one point? So where would that point or that plane have to go through so that it's just a little dot, just a little point, and it would have to be at the top or the bottom because it would just land right at that very point. All right, so let's take some time. In the following exercises, the points at which the slicing plane meets the edges of the right rectangular prism have been marked. So these little dots represent where it's been sliced. Each slice is either parallel or perpendicular to the face of the prism. That means that it's going to be parallel or it's going to be perpendicular, forming 90-degree angles. So we're going to use a straight edge to join the points to make the outline of the rectangular region defined by the slice, and then we're going to shade it. So number 2, we're just going to connect the dots, essentially, making that rectangular slice. And this right here, I'm just going to shade it so it's a little bit easier to see. This is your slice. Notice that it's parallel to the two sides. It's perpendicular to the top and the bottom. All right, so we're going to do that again. We're going to connect the 2 dots, or the 4 dots, I should say. I'm using a straight edge to do that. I'm going to shade it just so it's a little bit easier to see. So that would be your slice. All right, and the last one, we're going to take our straight edge again. And we're going to shade. So that's where we are slicing. Now, the next page, we're going to do the same thing, but now we're going to start to identify what that slice actually looks like. So real quick, let's do the same thing and create the slice by connecting the dots. We're going to shade it. Now it says to actually draw what that looks like in a 2-dimensional shape and then provide the dimensions. So if you look, this is like a tall and skinny rectangle. It's actually short and fat if you think of it that way. So I'm just going to kind of tilt it so that we can see it. So this would be the rectangle. Now the dimension of the front is 20 millimeters. The dimension of the height is 13 millimeters. And you can get that just by looking at the diagram. All right, let's do number 6. We're going to create the slice first. I'm going to shade it. Now this is a tall and skinny one. And then I'm going to just draw this, and I'm going to label the dimensions. So this along the bottom would be 8 millimeters. And the height of this, looking at that diagram, would be 12 millimeters. So that's what it would look like if I drew it flat. All right, so let's go to example 2. This time they already give us the slice, and we're going to answer some questions based on this. So the resulting slice is a rectangular region that is identical to the parallel face. So it's identical to the front and back here. It says label the vertices of the rectangular region as W, X, Y, Z. So we're going to create this as W, X, Y, Z. To which other face is the slice parallel to? So if it's parallel, it means it never touches the front and the back. So the front, if you trace it, is A, B, C, D. That's the rectangle in the front. Now the rectangle in the back, if you trace it, is G, F, E, H. That's right in the back. Now, based on what you know about the right rectangular prisms, which faces must the slice be perpendicular to? Well, if it's parallel to the front and the back, it's going to form 90-degree angles with everything else. So the two sides. So this left side, just trace it, is A, G, H, B. The right side, if you trace it, is D, F, E, C. It's also perpendicular, forms 90-degree angles with the top and the bottom. So the bottom right here is B, H, E, C. And the top is A, G, F, D. That's the top. So those are the 4 that it is perpendicular to. All right, the next one. It says the right rectangular prism in figure 5, this one, has been sliced with a plane parallel to face LMON. So LMON is this side. So it's parallel to the side. Now let's label it as R, S, T, U. Now what are the dimensions of this slice? So if I were to pull this out, what is this length right here? You can get that from there. So that's 10 centimeters. And the height you can get from right here is 11 centimeters. So it's a 10 by 11 rectangle. All right, part C. Based on what you know about right rectangular prisms, which faces would it be perpendicular to? Well, if it's parallel to the two sides, then it's got to be perpendicular to the top and the bottom, the front and the back. So let's look at the top. J, P, O, M. Just trace it right around. K, Q, and L is the bottom. The front is J, K, L, M. And the back is P, Q, and O. So it's perpendicular to those 4 faces. All right, last page. So the right rectangular prism in figure 6 has been sliced with a plane that is perpendicular, 90-degree angles, to BCEH. BCEH is the bottom. So let's label the vertices as W, X, Y, and Z. So which other face is it perpendicular to? If it's perpendicular to the bottom, it's also got to be perpendicular to the top, which is A, G, F, D. That's the top. What is the height of the rectangle? So this rectangle right here, what is the height? The height is 6 inches, the same as the actual figure. Now, Joey looks at W, X, Y, and Z and sees that the slice may be a parallelogram. It's not a rectangle. Based on what you know about the slice that's made, can he be right? Now, it's perpendicular to the top and the bottom, remember? Perpendicular means it forms 90-degree angles. And once you have 90-degree angles, it has to be a rectangle, not a parallelogram. So the slice contains 4 90-degree angles and must be a rectangle. All right, I'm going to have you try the homework tonight of the problem set, and I will go over that in class tomorrow.